Yeah, we were just asking if we need just the Arduino board and that's it.
Yeah, basically you need the Arduino board and some of the parts that come in the kit. So we can see I'm currently using just a few resistors. These are the circuits that we're going to be using. We only need one board, but we're going to basically be using. Actually, pin my video, spotlight it. Okay. So like basically we're just going to be using like just a couple buttons, a couple resistors, some wire. Keep it simple, and then the fun part, which is ultrasonic sensor here.
Oh, cool.
So yeah, so basically this meeting is all about sensors and interacting with the Arduino. And these three sensors that I'm going to address are actually four. So we got a photoresistor. This is going to be what we use to actually do edge detection. We're going to use this bad boy, a button, and then an LED, and then an ultrasonic sensor there. So that's basically what we're going to be covering today. Do you have any questions about that? Or
I'm just looking forward to learn. This is all new.
Okay, so did you guys find the PDF? I know only like told people to go find it like 10 minutes ago. Did you guys find the PDF in the Google Drive? It's tutorial 2 PDF.
I didn't see it. I'll look at it now.
So there's tutorial 2, there's a PDF, and then there's a zip. The zip actually contains the code that we want to use. And we're going to use that in a minute. Once I show you guys how to do the circuits, and then tutorial 2, the PDF, actually shows us through the actual making of the circuits. So I made the PDF like last year-ish, so I had to reassemble all my circuits. So they won't look identical, but they do the same thing. There are some typos. One typo I didn't have time to fix, mostly because I didn't know how to I needed to update a photo. I didn't know how to last minute get a photo onto my Windows computer. I'm used to writing everything on my Mac, so that was fun. So I decided, hey guys, I'll just tell you what the typo is. It's one little thing. It did trip up somebody last year, so I'm like, well, of course I need to fix that and address that for sure. So yeah, I guess before I get started, I do have some questions for you guys. I think one or two people were hoping that there would be meetings next week during reading week. Do you guys want a meeting next week? Otherwise, I'll just shift everything down schedule-wise. If you guys don't want to meet during the reading week at all. It's kind of up to you guys. I know some people like to work on their bots during the reading week. So I'm not sure.
I mean, I'm okay with either. Like, I don't mind if we have a meeting or not. So.
Yeah, me too. For me, I think my preference is for it to not be on reading week, but if it is, then I'll still come. So.
Okay. I want to slaughter this name again. Phi. What's your opinion?
I'm not quite sure yet. Perhaps it'll be fine either way.
Okay. Because I want to confirm that probably by tomorrow, so everybody knows what their reading week could be like. I'm hoping it'll be okay since it's like 8:30, so if people want to go out and do stuff during the day, it's not like the worst in the world. But I know kids these days like to stay out late. Me being one of those kids. So I'm not sure. So we got mixed results, I guess. So I'll keep it like that. I guess I'll put it up to a vote. I'll probably lean towards for it because I think it'll pay off in the end because there's going to be so many tutorials over the next 2 months-ish that by the time I hit my last tutorial, if I have to shift that a week forward, it won't spoil into exam season at all, but it's going to be that week of hell that we all know. It's going to be everybody needs to finish their assignments, get everything handed in. Nobody was going to attend a meeting that
Oh, I
week.
see.
So I think for that reason, I might do it on reading week. Although I do have a couple break weeks that I might be able to subtract, if anything. Those are great if you guys want to like work on your Sumobot, and I'm just here, ready to answer questions, and you don't have to like pay attention to a tutorial or whatnot. Okay. I guess so. You guys have the PDF.
Yes.
And I forgot to tell you guys to download Arduino. I just realized now. It shouldn't affect too much. Because I know Feliz, you've done Arduino stuff, so I assume you have it on all your computers. But Richard, all you, do you guys have Arduino downloaded at all? Because I'll quickly show that, and it'll be super
No, I
quick.
don't, unfortunately, but I can get it now.
Okay, I assume you could probably manage it, but for everyone there, Arduino IDE. IDE stands for Integrated Development Environment. Fancy dancy. And then it's just here, Arduino CC and software. And then you just click on the one you want. Of course, it's going to highlight Windows for me, but for others, it'll highlight Mac or whatever. And then that's that. It's just download, install, as simple as that. It's easy enough to uninstall if you don't want it. It's not like scamware or anything. Arduino is literally an Italian company. I think we can trust the
Really?
Italians. They never switch sides or anything last minute. So, anyways, that's for that. The PDF is So I'm gonna run through the PDF with you guys and kind of show with my camera what I mean by everything, and kind of take that route. And please tell me if I'm going too fast or anything. It's a workshop. It's not a lecture. So, yeah. So basically, first page I have, what is this? The second page. I have like some small cheat sheet things. They're basically some useful reference, so you actually know what these components are and what they kind of do. So I have a photo of a breadboard here, which are these things. You guys can see the camera on the side, right? It's like big enough. Or should I like stop screen sharing when I want to show something on the camera?
Yes.
No, wait, yes to what?
Oh, yes, we can see it.
Oh, okay. Okay. So basically, this is a breadboard. Your guys is probably white. Currently, I bought a pack of 6, and then the white one's actually on my Sumobot. But they look like this, and basically the way that they work, according to the photo, ignoring those red and blue lines, because these are mini breadboards, so they don't have that. Basically, each column is connected. Do I have a board I can? Oh, I do. Right here. Here's a white one. This is my own. This one has a little Arduino Nano on it. But if we actually peel it back, we can actually see how it's connected. This is basically, I just turned it upside down. And basically, each column of pins are connected, minus the middle. The middle is actually it's all sliced out. So this column doesn't continue across. But basically, each column is connected. So in this case, if we want access to all my Arduino pins on this little Arduino Nano here, I just plop it right in the center, and then it breaks out each pin for my use. So we're going to take advantage of that to connect some of these circuits here on this breadboard. And here's like a basic diagram of an LED of what the plus and minus is. Don't worry if you connect an LED reverse. Basically, it just won't light up. You flip it around the other way, it'll light up. As simple as that. There's other components out there that will literally explode if you connect it reverse, but the LED is not one of them. Here's programming the Arduino, which is another cheat sheet thing. You should come back to this once you want to actually program your Arduino, and we'll cover it in grave detail and go over it multiple times. So the first circuit I want to do with you guys is a light sensor circuit. So I'm actually gonna take this away. I don't need my keyboard. So I think this is far away enough. basically, we need to make a little light sensor. How does it work? It's very simple. Basically, this little module thing that you see here, which should be in your kit, and you should have one, or you should have more than one at least. Come on, focus. Basically, it's a little photoresistor. So basically, the resistance of this element changes according to light. And we need to basically detect what is that resistance. Not exactly, just more like relative, like how much is it changing? And then we can fudge the numbers a bit and do some fancy stuff. So the way that we achieve that is this little circuit. So this photoresistor here on top, and then this resistor on the bottom, it acts as a voltage divider. So if you have 5 volts on the top and then ground on the bottom, it'll literally like divide the voltage in two. The exact ratio, so is it closer to 5 volts, or is it closer to 0? Is it right in between 2.5 volts? Depends on what each of these resistors are valued at. The math we don't exactly go into because I don't think it's worth it for this workshop. We don't need to be tested on it. Basically, this kind of acts like a 10K resistor. So a 10K ohm, 10,000 ohm resistor, and then this bottom one here will also act like a 10,000 ohm resistor, because we're actually going to install a 10,000 ohm resistor here as by the diagram. And basically, this 10K ohm resistor in quote marks will vary. It'll just go kind of go up and down with the light levels, and then we'll use this here, this pin. So it says this line, this little green line, will go to the Arduino itself. Well, all of them will, but specifically this middle one will go. We can actually see it here. This little green line here will go across into the analog input, so of the Arduino. Ooh, come on, focus. We can see it's going straight into A0 here. And we're going to take advantage of that A0 because the analog inputs can actually sense voltage. That's what they do. They act like a super, super basic multimeter. They convert that analog voltage from anywhere from 0 to 5 volts to a number that ranges from 0 to 1024 in this case. Just goes up and down. Very simple. You can very easily implement that into your code. Like, if this is less than this, do this, or if greater than this, do this. Very, very simple. Do you guys get that? Understand that?
I'm just trying to like follow that and find all the things you're showing at the same time.
Oh, okay. So I guess I should show this circuit here in more detail. I actually stopped screen sharing in this case, so it's nice and fat. Focus. Okay. So basically, we can see here. I'm gonna actually get a little pointer here. We have 0.1 here. So that's like if you look back at the PDF, that's like the top that connects to 5 volts here. And then this is the middle pin with that green line that goes up to the Arduino, that A0 pin or A whatever pin.
Yeah, I found that.
And then this one here, see how it's connected in that kind of column? This goes to ground. And we can see over here, note how here's the black on the left, the middle is the green, and then the white is over here. And then we can actually pull up here. We can see minus my small fudge. Ignore that, pretend that didn't happen. We can see our black, big board's about to fall off the desk. Okay, we can see our 5 volts here is connected up. And let's lift the pin up again. Oh my God. Here we go. Okay, third time's a charm. So basically you see 5 volts going to the black. We see the ground going to the white. And then we see A0 going to this green middle one. You got that?
So ground is so all right. So black is A5. Ground is it should just say G and D.
Yeah, ground is G and D, and then positive. Sorry, this camera angle is really narrow. I'm not used to it. And then this, yeah, that 5 volts there. That's your positive.
And A0 is green.
Yeah, if you just end up putting in an A1, 2, 3, 4, or 5, we just need to change the code a bit to say, hey, actually read the value from this pin instead of that pin, because they all technically do the same. That's all.
So this might be a foolish question, but is there like what was the reason towards deciding which pin goes where?
This is a pretty standard design, this resistor divider. Basically the way a resistor divider, since it's like almost like electrical fundamentals, like basically you have a device, this resistor, you need to sense this voltage. You basically need to turn this change in resistance into change in voltage. Like basically the whole goal with like electronics and sensing is that you need to turn some kind of value, something, into a positive or a change in voltage, and then a microcontroller can pick up on that and do stuff with that. It's really just a standard design. So I needed some kind of positive voltage for this voltage divider. Focus. See, if you tell it to focus, it'll actually focus. I needed some kind of positive voltage. In this case, 5 volts, because this Arduino works on 5 volts. So if you want to output something to an LED or something, these pins will all output 5 volts and such. Then we need ground. Of course, every circuit needs a ground. That's the rules. Some exceptions, but 99% of the time it needs a ground. And then we have something to read in that analog data, and that's kind of known about this Arduino is that if you need an analog value of some sort, which is a change in voltage, like an infinitely variable change in voltage that goes up and down and whatnot, you need to use those analog ins. That's the whole idea.
Okay. So could I think of the black wire in terms of it being like an output because the green's input? Or is that wrong?
I would say neither output or input. Like current, technically, yeah, it comes out of the positive and through the circuit and then back down to ground. The way you should think about it is there's actually there's almost like 4 categories. You got your positive, your minus, your inputs, and your outputs kind of thing. So I would say it's because usually when you would describe an output, it's something that you can control, something that can go high or low with your code. So I would just consider it kind of your power input to the circuit and your power input to the circuit. You catch it?
Yeah.
Yeah, ask all the questions you want. Like I'll teach about terminology for hours if you want. Right. So that's our first circuit. So if you guys all want to try and assemble that, I would say go for it. So this is a 10k ohm resistor, and then this is our photoresistor, and you kind of recognize that. You can kind of pull it out of your kit. It'll be there. It'll be nice and easy to see. It's very unique, kind of very, very, very cool looking part. Get a close up. Come on, focus. Do it. Force it. There we go. It's a very, very, very pretty looking part.
It should have that squiggly symbol to identify it, because I'm looking for it.
It's not a squiggly symbol to identify it. It's actually the actual photoresistive material. That'll change. But yeah, that little squiggly is your spoiler. Right there.
Yep, I found it.
Amazing. Okay.
So
Louise, Mohammed, how you guys making out?
So I realized that I don't have a breadboard at the moment. I don't know where I left it, but I have double-sided PCBs. I guess I have to solder it for this.
You're gonna whip out your soldering iron and do, I guess, turf board stuff like this or whatever.
Yes. Is it double-sided as well? Oh, okay.
Okay, my design is double-sided, guys.
Oh, cool.
Ooh, look, pretty circuits. Yeah.
That looks really nice. What is that for? Like,
This was for an old project. I still got to use it. Basically, there was a rotary encoder here, and then it's just 4 buttons. That's it. And then it basically interfaced with a little microcontroller. It was meant to be a front panel of a little FM radio. I'm still working on finishing it.
oh, nice.
Can I pan over to the just giant pile of crap that is the FM radio? It's just a giant pile of electronics. Like I got a little audio amp over here and whatnot. Yeah, it's not a fun time. It's just my little pile of engineering over there. Got even some cute little USB-C things, so I can futurize all my components and stuff. Anyways,
Your table looks quite clean, to be honest. Like, there's no cutted wires or something, you know?
because this is the desk that I do like work on, so I actually gotta keep it clean. I don't have like a hobby desk, you know. So it's just all like, just work. Like I usually have my keyboard and whatnot. Clear it all off for the meetings. Anyways, yeah. If you could, I guess for the circuit, yeah, you kind of need some kind of breadboard. There's no like alternative, either perf board or breadboard in this case. Yeah.
I guess I need to order that one.
Do you like actually use breadboards in projects? I don't know. Or...
Currently, I'm not using it, but during my undergrad, yes, we used a lot. Like, we're not kind of designing our own PCBs or anything, but we're using for like simple projects.
I see. Okay.
But I guess
I'd recommend it for the Sumobot, the final Sumobot. Here, I should show it. My final design had a little breadboard on it. It was pretty handy.
Can we do it with the board? Like, can we use PCB instead? Would it also work?
You're talking like perf board, right?
Yes.
Yeah, take a look. This one here actually used perf board. How convenient that I have 2 Sumobots in with both your questions, or both versions. So you can see there's a little button soldered on here. You can see there's the Arduino. In this case, they use a different model of motor controller. And yeah, there was a metal plate included here.
Mm-hmm.
Yeah, so that's that.
Oh, cool.
Thank you, autofocusing, for just failing me there. Okay, should focus on that. Okay. Okay. So I'll let you guys, build the circuit. And we'll just jump, as soon as we do this, we'll just jump right into trying to program the Arduino. I know we're already in like half an hour, so we'll try and if people have to leave, at least they got the gist of it, and we can do the ultrasonic and stuff for the people who have time. The ultrasonic, the button, and whatnot. Because all that code that I provided is complete. Like, it is completely complete. Like, as long as you have the pinout correct, it'll work, kind of thing. Not so true with my algorithms and the actual coding of the bot, but we'll get there. That'll be another meeting. If anybody wants to turn on their camera and show what they're actually working on, feel free. I know if people have those camera angles set up or anything, but Go for it. Personally, what I should be doing is working on my Sumobot a little bit and actually replace some stuff on it for actual visual entertainment, if you want to say that.
Are you planning to like make a new design for this suit?
I actually want to like see how well it actually performs in an actual battle first.
Mhm.
The Sumobot is literally over a year old, and it has not pushed another Sumobot off the rink. It's hilarious. Yeah, I would probably want to see it first, see how it performs before I go into design a new one. What I really should have done this year, though, is totally design one with the cheaper wheels and whatnot, so people can actually have like a visual of what a final product should look like for that. I only have 3D models of what a possible design is for those. I know Mohammed's back, but are you gonna attempt the wheels, 3D printed wheels?
Oh.
I still like don't have like a clear idea of my design, but like I'm gonna think about it hard in the reading week, and then I'll know if I want to design them or if I'm just gonna.
Yeah, okay. I want to see some of you guys submit prints. Nobody submitted prints last year. A lot of people just used cardboard and stuff. I want to see people like submit prints to print. So
Yeah, I
these
want to
3D
3D
printers.
print.
Yeah, they're primed and ready for whenever you guys want to print. I don't think I've taken apart the Sumobot since I got it. All right. Let me know when you guys have, or at least a couple of you have designed or gotten your kind of circuit together.
So I have a question about the 3D print. So
Yeah.
I see you're showing this. So that screw, was it drilled into the 3D print, or was it like already 3D print with a screw hole? Because I saw the whole feature, right? And it's like interesting. Like, how do you get it exact to get your right screw size?
It's a really good question. So I've actually been just learning about a few different solutions, kind of on the fly. So basically, you wouldn't usually use the hole function because those are for like threaded holes into metal. You usually just use the extrude, because all you really need to do is make a hole that is slightly smaller, or sorry, excuse me, slightly larger than this actual screw. So this is a M3 screw, which means it's 3 millimeters in diameter. So basically, I would make a screw hole that is 3.2 millimeters across, or 3.3. Just literally just a hole. Like you just take the circle tool, type in 3.3 millimeters, and screw it in, or drill it, extrude it, and then your screw will fit through. But if you make the hole slightly smaller, you shrink it to less than 3 millimeters, then that's something you can actually thread into with like literally like the screw will actually screw into. With my design, I did use M3 screws and stuff. I didn't tell you guys to buy M3 screws, mostly because you can actually get away with just hot glue. And I would save you guys some money. But if you want to take the route of using M3 screws and whatnot, like I totally encourage it for sure. Did that answer your question of like best method with the holes?
Yeah.
I didn't actually like drill through the plastic. I had to design it into the 3D model. Otherwise, well, we would be screwed. Can I say that?
Also, what's the like the infill on the thing on like the 3D print, or is it like 100% infill?
In my case, I use like 20% infill, but since these parts are so thin, you don't really get much infill. So yeah, Richard, did you make it with the circuit? I know you found the photoresistor. Did you get it all in?
Yes, since then I was trying to find the wires. I got the wires. Now I'm trying to find I'm not sure of the name. It's the thing next to the photoresistor. It's blue.
Yeah, the resistor.
That's just called a resistor. Okay. I'm not
So
sure.
they kind of come packaged like not in a bag, but they kind of come packaged like this, and they kind of unroll like such. You get like 10, I think, in your package. I actually bought like a huge ass box that you can see over here. Such a giant box of resistors. Been very handy for me.
Oh, I just found them.
Amazing.
Yeah, I should have also probably, organized my resistors, but like from the past, when I used them, I did not. So like now I have to go online and search the code for, the specific resistor and try to find it from just a box of resistors.
If you guys have like a multimeter, that might be a good strategy. I don't know if any of you guys have one.
I think we were supposed to get one for one of our first year courses, but from the bookstore, but they ran out. So now we're just like waiting.
EECS
10,
11. Oh, he told us, James Smith told us to buy a multimeter. He did. Whatever. Was it James Smith? Is James Smith teaching a course? Or?
Yes.
James Smith is actually an amazing prof, though. If you guys do kind of
He's
EECS,
awesome.
you have to do embedded systems with him, I think.
We're doing object-oriented programming next semester.
That is not taught by James Smith, unfortunately.
No, he said that he's teaching it next semester. He literally told us that
What?
we'll be learning that with him next
Oh my
semester.
god. Damn. I didn't get him. It wasn't a great course without him. It would have been amazing with him.
Are you guys talking about the 2030?
No, first year.
No, we're all
Maybe
first year,
first year.
sorry. So all 10 courses.
Are you a master student? Out of curiosity.
Yes.
Oh, that's really cool.
I mean,
What are you doing?
nothing fancy, to be honest. I'm doing my MA in digital media. I don't know
That's
what
cool.
comes to their minds, guys, but it's not about media, so I can assure you that.
Is it about digital stuff or?
Actually, it's kind of like we have a lot of common courses with computer science majors, and
So is it more on the game design kind of side, or?
Mixed. Like we're working with VR stuff, gaming, like building stuff using Arduinos or like Raspberry Pis. We have like different streams, especially like in undergrad.
That's cool.
Yeah. Kind of mix.
You guys design like user interfaces? Is that part of it?
Kind of. We had like I actually took a course in ECS. It was a user interface course, like both. I did the third year and the fourth year ones. So yeah, if you're interested in that, you can take it. But like our department doesn't provide it specifically. Like we don't have it.
Oh, that's a shame.
Yeah, sorry.
Sorry, go ahead.
No, I was just gonna say it's really interesting. I didn't know that was digital media about.
Yeah. Yeah, it's nice. I mean, it's kind of good to have like both computer science and like arts kind of combined in one.
Yeah, it is. I agree.
It's
you
very
guys,
true.
You guys know more, so I think that's much better. You guys know more on the technical side and stuff. So we kind of lack in terms of like the technical parts. We don't have much knowledge in that sense.
But yeah, but I can't draw for crap.
I mean, I don't know. Yeah, what? I know.
Like my mom kind of did the opposite, and not the opposite, but kind of like the other side of digital media, which is graphic design.
Oh, cool. Yeah, graphic design is nice too.
And I watch her go to like one of those like family paint nights and wipe the floor with everybody's paint. It's really funny. But yeah, digital media is really cool. I knew somebody else who was taking it, and I saw them like literally designing a game, and I was like, damn, I wish I could have fun like that.
I mean, I think you guys can also take courses from our department. So
Really?
yeah, for
Oh, I did
sure.
not know that.
We have like gaming courses and stuff. Like if you're interested.
Oh,
in-
the gaming thing sounds really cool.
Yeah, like they're teaching animation, modeling. You know, it would be nice if you're interested, of course.
Yeah.
I ended up taking all these electrical engineering courses, which were boring, but I have to get a job. That is the life. I don't know if you guys have noticed me struggling. I stick my breadboard down, and there's a screw underneath the breadboard, and it's stuck down, and I can't get it off. So I can actually like replace these little wheels. Don't mind me struggling. So are you guys? How's the circuit going? Is it going okay?
Could I show you my screen? I got all the parts and I they're on the breadboard, but I didn't place anything correctly as yet. I'm not too sure where things are supposed to go.
Do you want to see the diagram again? Or there's a picture in the
In the PDF.
Yeah. Is that too confusing, or is it?
So the breadboard I have isn't colored. So I'm a little
Okay,
bit
the color doesn't change anything, I'll tell you that.
yeah.
What's confusing then?
All right. Well, I guess I'm just trying to figure out where things go. The wires, like they're connected to the Arduino correctly.
Yeah.
But
do you need a close up of this one, or?
Okay, the photoresistor and that. Yeah, that looks. Yeah, that's. Like. Does it matter which pin the photoresistor and the resistors are connected into?
Does it matter? Sorry, which what?
Which pins the resistor and the photoresistor are connected into? That
in this case, they all right here. They have to be all in the same column. They have to share.
Okay.
In this case, as long as this pin here is aligned with this pin, you're okay. And then, as long as this is in the same column as this pin, then you're okay.
Okay, I'll do that.
It doesn't have to be in the exact column either. Like I could move this resistor just one pin over, like such. So you see it's on the second to last, but now I have to move this white pin
so
over one pin to match. Yeah. It's all about matching up those columns with what you want to connect. There we go.
Okay, I'll try that.
Damn, this camera is so nice. Why wasn't I using this before? Guys, I'm blown away.
Also, the Arduino is supposed to, like, is there a way to connect it properly to the breadboard?
What do you mean by that?
I just noticed there are those spikes on the bottom, and I was wondering if
on the smaller one or on the smaller one here or on the bigger one?
The bigger one.
Okay. Like, are you talking these spikes?
Yeah. What are those for?
Those are literally just the pins themselves, just kind of the opposite. the opposite
okay.
side. They really serve no purpose other than to annoy you, scratch whatever surfaces you drag it across, and electrocute you if you pop this on a metal surface. Yeah, they're just kind of an inconvenience. They're just kind of a flaw in the manufacturing process.
Mm-hmm.
And if you get really heavy into PCB design, you'll understand exactly what these are and why they exist. These are known as something called through-hole components. So they actually literally have to poke through.
Through the hole.
And you,
Okay.
and you see this little chip here. That would be a surface mount component. So you see, because it's little pins, it focuses, don't actually poke through on the other side. Random rant, but yeah, it's just a manufacturing thing.
All right. Got it.
So you can kind of see with mine, I'm just shoving in these pins into the top, and then they go across like such.
Yeah. The thing is, I'm doing this on my bed.
I see.
My bed is covered with these parts.
Okay, I don't know if I can actually disassemble my Sumobot. I didn't realize this stuff was sticky.
Right, there was something.
Wow, I really destroyed that breadboard. Oh well. Through my destruction, you can visually see all the rows of the breadboard connected. And if we actually pull the one that I accidentally pulled it.
Wasn't like there should be like a sticky part at the back, right? Oh, it's
Yeah,
I see.
Yeah. I just want to disassemble my Sumobot so I can actually fix it properly. I'm just gonna get some double-sided tape and just stick it back on. No biggie. It held for like an entire year of being tossed around in these meetings, and, you know, into the basement, out of the basement, making my tutorials and showing all my friends and being like, "Hey, look what I need to do." It survived, so double-sided tape should be just fine. Louise, have you already cracked out that soldering iron and already soldered the circuit together and everything?
Well, I'm not that quick, unfortunately.
If I knew, I would have challenged you to a race.
I have my stuff here, but yeah, it's gonna take me some time, to be honest.
All the way across my desk over there, I got my soldering iron primed and ready. Like, just say go and I'll do it.
Actually, I would like to ask you guys about like what, like, do you have like any suggestions in terms of electronic books? You know, I don't know, like what, like any PDF or like book that kind of explains the all the electronic parts.
That's a really interesting question. I had a book, but it was for electromechanics, so it was motors and whatnot. It's a very old book. The ones I use for my courses are pretty lame. I think I learned 90% of my stuff from Google and YouTube. There is like like, you know, when you learn Java, there was like this website. It was like Java workshop, or I forget what it's called, but it had a breakdown of everything. I
Yeah.
assume there's a website like that for electronic components that you could probably find. That does all that kind of breakdown for you, and it might be your best bet. I don't know. Are you like a fan of reading? Is that why?
Not really, but sometimes it's hard to find like the I don't know, like I want to maybe like focus on certain projects that require certain components, electrical components, and I don't
Like
know
what kind of components?
I'm just like giving an example. Like I'm not currently doing anything, but it happened before, like in the past, and I was like struggling because I don't know the names and I don't know which part will actually work the best for that project. So I didn't know those things, and
Oh, I see.
search it. It's kind of hard to find sometimes because like it's hard to describe things. You can't just say like I don't. You can't just describe the project on Google and then it, I don't know. It's just yeah.
Well, I guess you would kind of. I guess what the key is kind of being able to break down your question into like the smallest kind of segments. Like, for example, I want to do edge detection, right?
Mm-hmm.
So, and how does edge detection work? Well, it senses light from dark. And then I would Google how to sense light using best electronic component for sensing light, and there would probably be a full-fledged article on it. What was your project to kind of give me a whole perspective?
We were planning to kind of create this keyboard wall, but we were thinking about like hundreds of keyboards, and we kind of have to like code it like you have to kind of combine that, like, so we weren't actually using the keyboard, we were using PCBs and then attaching the keyboard buttons to that, like soldering the actual keyboard buttons to those PCBs, and then with wiring all those keyboard PCBs into one big like a wall kind of thing.
Yeah.
And we kind of needed this like we didn't really know how to kind of make this full wall work. Even though we connected things, we didn't know how to, because there's a lot of wires at the end, right? Like if you're thinking about like maybe 14 by 14, keyboard pieces, it will like you will end up having a lot of wires at the end, and you have to connect that to Arduino. So we were struggling. I don't know if that makes sense, but we were kind of struggling to kind of find this piece where we can manage to kind of get like the less wires at the end.
I see. Basically, I mean, I know the answer, but I guess that's not the point that you're asking. You're asking like, how do you kind of learn that stuff on the fly? In your case, you would use a concept called multiplexing.
Oh yes, that was the one.
Which you were told how to do that in a course that James Smith taught, coincidentally, in third year. But like, what I would end up Googling is like many buttons, how to control many buttons with limited GPIO pins, or how to sense many buttons. You would end up getting multiplexing for sure.
Yes. We ended up finding that. Actually, I've got the parts, but since I'm a bit like kind of lack of the knowledge of how to use that, I was kind of struggle at that. And
oh, I see. I guess you would hire an electrical engineer. I'm not gonna lie, like a lot of this is just bits. For me, at least, it was bits of information. A book that would teach multiplexing along with other stuff. Because I was thinking you were gonna ask something about like a transistor circuit of some sort, like an analog transistor circuit. But that's almost like an embedded systems question. So like there's multiple streams of electrical engineering, right? One of them being embedded systems, which is what we're doing right now. This is literally called embedded systems. So put that on your resume, guys. So I wasn't for James Smith course, which was embedded systems, which where I learned about multiplexing and whatnot. He literally did not give us a textbook, if I remember correctly. So
Was it like just lecture notes or?
Really powerful lecture notes, yeah.
Oh, I see.
So what it sounds like you should look for is like a really good embedded systems textbook.
Okay.
That's embedded systems is a very important term for sure. Mostly we spent an entire week discussing what embedded systems was in the course that I took. It's pretty fun. We have to go around taking selfies of different embedded systems around the campus. That was fun. How's the circus?
Can I show you what I've done?
Yeah, go for it.
Maybe a little weird to show on the camera.
Well, then let me remove my spotlight here.
They're lined up on, I don't know if it's focusing at all, honestly, but
okay.
I lined them up, but I'm not sure this is right.
There is a mistake.
Yeah.
The photoresistor needs to be moved to the left a fair bit. Like you have one of the pins, you remember how I said that middle column with the green? One of the pins of the photoresistor and one of the pins of the resistor has to go to that middle green wire, right?
Yeah. So, okay, photoresistor is the one that I said has a squiggle on it.
Yeah.
Okay. Yeah. So you were saying?
So it needs to, you need to get that whole pin sharing thing. Here, I'll show you on my beautiful HD camcorder. We can see that this pin here, I'm gonna pin my own video again. Hold on. I can actually like see what I'm looking at here. So that pin there, you can see they're all in the same column.
Oh, okay.
Oops, that's not pressed in. So we can see one pin of the photoresistor, one pin of that, and then the green pin, which is our fancy analog value. And then we can see the other pin that's going to our 5 volts, and then this pin of the resistor over here that goes to our ground. You following?
Yeah, I think so. I'm changing it now to what I think I see.
Okay.
Problem is that the metal is so sensitive, so like I'm trying to apply pressure, but I don't want to break it.
Yeah, pushing into breadboards, there's totally a trick to it. You wiggle it around and it kind of just sucks in almost.
Okay.
I've used breadboards for so long. I'm really used to it. It's really interesting to see all these problems that I totally forgot that I even dealt with when learning electronics are totally coming back up. You know, with you guys learning and whatnot, it's really interesting to see, for sure. Like I was where you guys were at one point. Like even later. Like I started learning Arduinos like beginning of 3rd year of university. Like that's how late I was to the game. You guys are get a nice head start on this stuff, which is great.
How long would you say it took you to pick it up properly?
A year.
Mm.
A year, and I was an expert, but at the same time, a year, and I was, I was also doing electrical engineering courses on the side, which helped accelerate that.
Mm.
Like I immediately, I see this circuit, I immediately know what it means. Like I analyze it, I know what it means. If I get the resistor value, it just makes sense to me immediately. As a result of these, second, third year engineering courses. But I know you guys you'll take your time for sure. And that's what accelerated and made it almost like a year. And then I was building a Sumobot like casually as my weekend project over the summer before Sumobot started. I was building an FM radio for a project. You know what I mean? Like
Yeah.
it really depends on the person and what kind of experiences you have. But for me, that's why it only took a year, at least. I would expect more, for sure.
Mhm.
Like, Felice, how long have you been working on with Arduinos and stuff?
So I was graduated in the game art stream, so I wasn't doing much with Arduinos, but like I think I can say I started in my second year, and I only took one course, but I was doing like side works. So, but I'm
So-
definitely like I think I need to work on that. Like I'm not good at it at all.
I see. So you just kind of been doing it on and off.
Yes, yeah.
I see. So wait, is digital media, is it a 3-year program?
It's you can do it 3 years, but it's normally 4 years.
Oh, it's normally 4 years. Okay. And you took 4 years?
Yeah.
All the crazy people take it for 3 years.
I guess like the 4th year is like we're doing our capstones mostly.
Mhm.
Like if you don't prefer to like waste your time with capstone and stuff, people usually prefer 3 years. And I think they can do
You can
like
just skip capstones.
I guess. But you'll be like BA rather than honors. I don't know if you
Okay.
but we have this difference where BA and like honor BA. So
Capstone was like the thing I was most excited about by far. So I was so happy to do it.
Sorry, I just have one question. Would you mind showing it one last time? I'd like to take kind of a screenshot so I get this right. I'm allowing them.
I don't lose my screw. Oopsie. Okay. I see where it is. I didn't lose it. Okay. On this camera, I put like a really nice macro lens. That's why it's like so nice. Like, look at that. You can just see everything going on here.
It's a little out of focus. Okay. Wait. Yep, that's awesome. Thank you. I will get this right.
Your determination, it means a lot. Can go far with that.
I hope so.
Again, I'll say it, like I was there. I was there trying to like figure out what the hell is going on with these circuits. It took a while. It did take a while. And
yeah.
I totally understand it. Look at that. Now I have a new drivetrain. Holders, at least. I'll guess. I replace these thick or these super thin ones with much thicker ones. Now
Okay,
I
I
just put
think
it all back together.
I think I got it. I made just one mistake, but if my computer will let me open up Zoom again. Oh my. Okay, is this better?
Okay. Ooh, that looks pretty good to me.
Okay.
I can't see what's going into the Arduino, but I assume you knew what to connect.
Yeah, so the green is on A0, the white's on ground, and the black is on 5V, 5 volts.
Yeah.
Awesome.
Okay, that's good.
Okay, finally.
We got there.
Okay.
Please, among the others, you all making out?
Pardon me?
Are you making out? Like, are you getting there?
Yes, I am trying.
What are you having trouble with? Just soldering, or
Yes, just soldering in general.
noting when you solder that you're gonna need to, like, I guess, desolder these photoresistors unless you have like a pack of 10 or 20.
Oh, I see.
I assume you like, I don't know how many you have, or what did you end up buying specifically?
So I had like the PCBs already, the double-sided ones.
Mm-hmm.
So I'm planning to use those ones at the moment, but I'm still considering to order breadboard as well. And yeah,
Usually, like, my design process goes where I make everything on a breadboard,
yeah,
and then I put everything onto a perf board.
that makes so much sense. Because otherwise, you like you don't know where to put things, right? Or you might like use like whole space in the PCB differently.
Yeah, I mean, this button thing I totally made on a whim. It was like an afternoon, evening, multiple hours. I don't like to admit how many hours I put into this, but since the circuit was at least simple, but usually, normally, you would want to totally.
I see. Okay, I'm just gonna skip this week then. I'll get my breadboard and then I'll catch up.
Okay. You can at least stay for the code.
Oh
I
no,
think we can.
I'm here. I'm listening.
Okay. Okay. We can move on to the code, Mohammed. I don't know how you guys are making out, but hopefully we're ready for the code. We're ready to go.
Oh my. I might hop out for a split second and then come back because my computer is being absolutely mental.
Okay. In the meantime, I'll just start opening up my code and whatnot.
Okay. Be back in a sec.
So basically, what I'm doing is opening up. So that zip file, I'm going into the zip file and I'm opening up light sensor. Sumobot _ light _ sensor. I'm opening that. I can actually share my screen. I'm actually opening it. So you can see I just opened it. No, I don't want a new version. Oh, this dark mode is like, it's like not great. It's dark mode, but it's not a good looking dark mode. So you can see as simple as that for the path, and then we have this code. Let me know if you guys end up opening it and or struggling with it.
Yeah, I opened mine.
Okay, awesome. So this code is very simple. It's a lot of comments, but it does what you want and nothing more, to put it simply. So, I mean, I'm really just going to demonstrate the code right now, and then I'll kind of explain how it works. You wait for Richard, because this is gonna get intense. Because we basically have to go through the PDF and follow it. How to program your Arduino. Yeah. So I'm just gonna plug in my Arduino, if anything. Yeah. Make sure you guys can see it on camera. It is Arduino with my little light circuit here. And I'm just going to take a little mini USB thing and pop it in and watch it explode. Oh, we're good. It won't actually explode. Okay, so we're in. Let's see here. So all I'm really going to do is I'm going to program the Arduino. Is simple as that. So I'm basically following this little tutorial here. Basically, it says you have to select, if you have an Uno, you have to select an Uno. If you have a Nano, select a Nano. Some people might have issues with the Nano, and I'll show you how to fix that. But I'm going to just do the Uno, because that's what I have plugged in here. The big one is the Uno. And we're just going to go over to Tools, Board. We're going to select Uno. And then we're going to select the port, which is going to be COM4. It actually tells me, which is really convenient. Richard made it back. Oh my god. So COM4. It might be COM something else, as we can see here. It depends on what USB you plug your Arduino into. All right, Richard, do you need some catching up for the code?
I'm just gonna follow along for now. My computer is really slow and it's trying to download Arduino, so I can just watch for now.
Okay. Basically, what I did is I opened up Sumobot light sensor file over here, and now I'm just working on actually coding the Arduino. And just to go over it really quick, I went into Tools, I went into Board, I selected Arduino Uno, because that's what I have here on Uno. And then I selected my port. The port is basically, where is the Arduino on your computer? It's COM4. And then basically you don't even need to do anything else, and then we just upload. So there's verify and upload. It's, yeah, what USB port, but like basically what's happening is there's a little, if we can explain it a little bit in detail, basically there's a little chip on here that actually connects to the Arduino, and that chip converts the USB signal into something called a UART signal. So you have to do some fancy stuff and say, hey, it's COM4 or whatever. It's the way Windows handles things. It's always complicated. Anyways, upload is what we click. So basically verify and upload, there's two buttons. Verify will verify. It will basically say, is the code okay? We can do that. We can click it and it'll say it's fine. It takes a few seconds. Upload will actually verify first and then immediately upload. So you don't have to like click both or anything. One's just kind of handy if you just want to see if it's working. So we're going to just press upload here. There'll be some flashy lights. Not that you can really see it with this lighting, but it says done uploading. Check it out. And now I'm going to open up my serial monitor, because what this code does is it prints the values to the serial monitor. So there's a little button up here. Hopefully it's not too small for you guys to see, actually. I now realize I'm using a really large screen. We can click it. It is not set up correctly. That's why nothing's appearing. 9600 baud, correct? And there we go. So basically you can see here, serial begin 9600, and it just has to match here. Your default install of Arduino will do it. So now we can see these values printing off. If you guys can't see it, it's printing off in like 879. And now I'm literally going to cover this sensor with my hand. And now it's 320, 300.
Oh, that's cool.
Let's see how dark I can get it. Like 10, 20, and then it'll brighten back up to 1000. If I get my phone light here and aim it, can we go higher? I want to max it out. Higher. 1000. So you can see it's almost pushing that 1024 that I talked about, and that's like kind of the limit. That's specifically with this art model of Arduino. Other microchips might go higher. So this is kind of what I meant as in analog. So basically on this chip, there's something called an analog to digital converter, and it converts that analog, that voltage that can vary from 0 to 5 volts, into a number spanning from 0 to 1024. And that's the sensor. So hopefully, Richard, you got that, right? Please, you got that.
Yeah, I was following.
Okay.
Yep, same here.
Awesome. Okay. And now I can kind of explain the code now. So I'm going to with my keyboard. I gotta like
Which programming language is this?
boop, boop,
The
boop,
C?
boop, boop, boop. There we go. This is Arduino C, which is more of a
Right.
derivative of C++ rather than C, because there's objects, as you'll learn in 1012 or something, like ECS 1012.
Yeah.
So basically this code here, I should have zoomed in from before. Basically we define two values. What is our pin number, and then what is our sensor value? We say it's A0. Arduino is really helpful because you can literally type A0 and it'll literally go to the A0 pin. If you use fancier microcontrollers, you've got to do some like table references and data sheet. It's all gross. But this is really handy. So A0, and then sensor value is 0. We just initiated at 0 because who cares? But basically, this is what your value will be stored to, that 1 to 1024 number. And then we set up, basically serial.begin is saying, I want to communicate with the PC, in this case, my computer, at a rate of this, 9600 baud, which is, it's a number. What you need to know is 9600 is standard, just leave it as 9600.
What's baud?
Argue it. Baud is, I guess, a slang term for bits per second.
Okay.
You would call it your baud rate. I think there's minor differences, but the same thing in this case. So 9600 bits per second, or 9.6 kilobits per second. And then we enter our loop. So the way Arduino code works is basically you have one function here, void setup, and then you have a second function, void loop. And then it'll run setup, this function here, so inside these brackets, it'll run that once, one singular time, and then it'll go into loop and just run it forever until the end. It basically runs it forever. So it'll always start at the top, so line 33 in this case, and it'll go 34, 35, all the way down to 42, and it'll go back up to 33, and just keep going, one line at a time, because it is a single core processor. We're not doing multi-threading. So we can see here, this is the gold right here. This is the line that actually takes in our data, and will be very useful for you guys come actually coding your Sumobot. So basically what it does is it does analog read, which is like, basically it's like, what is the value? What is the analog value coming from this pin, which we defined up here? See, analog pin, and then analog in pin, A0, so it'll just put A0 down here. What is that fluctuating value at that pin? Whatever it is, store it in here, sensor value. And it did that. For those who are really, really new to code, sensor value, the value on the left of the equal sign is what is the actual place to store it. And then on the right side is what value you want to store. So the left will always be overwritten by whatever is on the right. And then here is the serial stuff. This is where we actually communicate with the PC. When we say serial print in quotes and then sensor equals, so you can see it says sensor equals here.
I see.
And then with a couple spaces, that's why I already have the spaces, and then sensor value, print line. So when these are two different commands, so when you see line here, it'll actually print at the end a carriage return. So it'll actually go down to the next line. If we want, I can actually show what happens when we remove that. Just delete that, and we'll just get basically a giant. It will never return ever, and it will just spit out like this. It's hilarious, isn't it? I've had this happen to me many times, forgetting the new line. So all it does is just print in a giant row. Let's put that back. I actually need my keyboard now. Control Z and save that. And we can see here it prints every, and then the last command, which is also going to be really handy, is this delay command, which is in units of milliseconds. It'll basically wait here for 2 milliseconds before printing again. So if we do, let's say we change it from 2 to, I don't know, 200. Let's go 200. So that'll be about once every 5 times a second instead of whatever it was before. We quickly upload it. It takes a very short amount of time. I was coding something earlier yesterday. It took forever to upload. So yeah, now we can see here that the value is printing out very slowly. Is this big enough for you guys to see?
Yep.
Yeah, I was prepared to make it even bigger. So yeah, we can see it just going slower now. And I encourage you guys to just screw around with the code, see what you can change. Like if you change a value or a number, probably don't change this number, but changing this number won't do anything other than the very first value it prints at the beginning will probably be different. Nope, it actually won't. It won't change anything. So yeah, do you guys have any questions regarding this code? I know we only ended up getting to like the first sensor, but that's okay. I kind of split it up anyways. I think our schedule posted here. Yes, getting started with sensors too. So this is totally okay. Getting down the first sensor is kind of like the hard part. So hopefully you guys are on track. I guess this is it. I mean, we're already like, oh my gosh, it's like almost 10 o'clock. So I don't think I can go much longer. I do have code to write and stuff to do tomorrow for other assignments. I'm currently in a course called Computer Vision, doing a lot of photo recognition. I think, Felice, you probably took that.
Oh, I wish. I'm not. I think that requires a lot of knowledge. But is the professor? Wait, no. Who's the professor for that? James Elder is teaching.
Costa.
I'm not familiar.
I think he's from either Ryerson or University of Calgary, one of them. But I can. This is a Sumobot meeting, but I don't care. We can see computer vision. The Costa guy. He's not even in the chat. Never mind. Speaks to purpose. He's really cool. He created a Discord for us, kind of level. He posts memes for us. He posts on Twitter a lot. He's really cool. He does a lot. But computer vision, oh my god, so much linear algebra. It hurts.
Yeah. What are the requirements, like prerequisites for that course? I think.
I have no idea. All I know is that I had the prerequisites. But I know a lot of computer science kids are in there, and they are doing a lot of review for sure. I am too. It's matrices. It's like first year engineering. I assume, Richard, you're doing it right now, linear algebra.
Yeah, I am. It's a pain.
Yeah. Even to this day, I find it a pain in the butt. Damn, I was hoping you would take it, but like that course is going to take all of my reading week off for sure.
I think that's a great course, but I wish it was related with my with my projects and stuff. But yeah, it's not really, yeah, it doesn't really match up with my stuff.
Yeah. It's
And
unfortunate. Maybe you just saved yourself. I would have rather taken some other course.
I mean, I know that that's a hard course because like I don't specifically remember the prerequisites, but I remember that like it wants you kind of like a certain level of math and stuff, and I don't know, like which language are you guys using?
MATLAB.
Oh, math.
Oh, that sucks.
Okay.
They're moving next year. They're moving over to Python.
Thank goodness. Python's so much nicer.
Nice.
In 10.11, are you doing Python or?
I think well, no, we're using MATLAB, but I think next course we're gonna be using Java. But I did Python in the past. It's so much nicer.
Oh, you guys are learning MATLAB like in the first year?
Yeah, like as like basic functional programming or procedural programming. I'm not sure what the term is, but yeah, like basic coding stuff. We're using MATLAB,
Oh, nice.
plotting graphs and stuff.
That's so cool. Oh.
Yeah, I thought they would have moved that course, that ECS 10.11 course, into Python by now, because I think Lausanne wanted to move over to Python, which is like amazing when I heard that.
I heard that ECS 3311 is going to be trying Python now instead of Eiffel.
Oh, thank freaking God. Oh my God. I didn't have to take that course, but I know everybody else in the ECS department does.
What is 30?
Yeah, everyone hates it.
What is the course called again? What's the name?
Software design.
Oh, software design. I think Professor Ma is teaching that course.
I thought it was Jackie Wang, but I'm not sure.
Oh, Jackie.
It's Jackie Wang and a different prof. There's two different profs that teach it. Both of them terrible.
Wait, really? Jackie's bad?
Yes.
Oh, I thought he was good, from what I heard.
Because of Eiffel, I think it's a cross between bad prof, not wanting to curve, and then terrible language to learn, Eiffel.
Yeah.
Fortunately, I didn't have to take it, but oh my God, was every day I talked to anybody taking that course, they complained. Everybody, without fail. Not a single person liked it. There was literally a petition with Engineering Society back when to get that shit. Oh my God. It was bottom tier course, F tier, if you would have called it. Yeah. Good luck. Python will probably make it a lot better for sure.
Yeah, I'm sure it will.